Hello students! Welcome to Math&Magic. For today's video, we will talk about the different theorems related to circle. This includes theorems about radius, chords, angles, and proofs. This video also highlights the rules you need to remember to work out some circle theorems. But first, let us define a theorem. Theorem is a major result that has been proved to be true using operations and facts that were already known. Some of these theorems that I'm sure you know by now are the Pythagorean theorem, binomial theorem, and others. For the first theorem about circle, this shows the relationship between the radii and chords of circle. It says that if a radius is perpendicular to a chord, then it bisects the chord. In case you are not familiar with the terms perpendicular and bisect, when we say perpendicular, it is the relationship between two lines which meet at a right angle or forms 90 degrees. Meanwhile, bisect in geometry means to divide or cut a line into two equal parts. Now to prove this theorem, we will use the SR proof or statement and reason inductive proving. Given circle O with radius OD, if segment OD is perpendicular to segment AB, a chord, at point E, prove that segment OD bisects segment AB. Constructing a table with two columns, here we will label the first column for statement and the second column for reason. Also take note that since we will follow inductive proving, we will begin by stating the given assumptions, then use some properties to arrive at a general statement. And from there, prove the indicated statement. For the first theorem, the first statement is radius OD is perpendicular to chord AB at point E. For its corresponding reason, we will write given. Remember that this assumption is already stated in the beginning. For our second statement, here we will draw radii from the center to the points of the chords A and B. Thus, radii OA and OB are formed. For the reason, we say that 2 points determine a line. Third statement, we will conclude that radius OA is congruent to radius OB. For the reason, we know that the radii of a circle are all congruent. Now notice in the illustration, two triangles are now formed. Those are triangle OEA and triangle OEB. This may give us a clue that triangle similarities can be used in this proving. For our fourth statement, we say that segment OE is congruent to segment OE. And the reason, this is reflexive property. Here we now have two parts being identified. One more statement and we may use triangle similarity theorems discussed when you are in grade 9. For our fifth statement, we say that angle OEA and angle OEB are right angles. Reason, definition of perpendicularity. In the first statement, we say that segment OD is perpendicular to segment AB at point E. So the angles formed there are both 90 degrees. With this information, we can now say that triangle OEA is congruent to triangle OEB. Both of them are right triangles. For the reason, it is by definition of right triangles. A right triangle has an angle whose measure is 90 degrees. Now recall that there are two triangle similarity theorems applicable for a right triangle. Those are LL or leg-leg similarity theorem and HYL or hypotenuse leg similarity theorem. In this proof, Statement number 3 provides information for the hypotenuse, and statement number 4 is for a leg. Hence, for statement number 6, we can say that triangle OEA is congruent to triangle OEB. That is by HYL theorem or hypotenuse leg similarity theorem. Given this generalization, we can conclude that segment AE is congruent to segment BE. That is by CPCTC, or corresponding parts of congruent triangles are congruent. With this, our last statement would be segment OD bisect segment AB. And the reason is by definition of a bisector, since the line AB is divided into two equal parts. And that ends our proof. As an application of the proof, let's try to answer some exercises. For item number 1, radius OB is perpendicular to chord AC. Segment AD is equal to 3/4 x plus 6, and segment CD is equal to 1/2 x plus 8. Find the length of segment AD, segment CD, and segment AC. Again, as stated in the theorem, when the radius is perpendicular to a chord, it will divide the chord into two equal parts. This means that segment AD is equal to segment CD. Here we will equate 3/4 x plus 6 by 1/2 x plus 8. Combining like terms, we will transpose 1/2 x to the left side. It will be negative 1/2 x. Positive 6 when transposed to the right side will become negative 6. Performing the operations, 3/4 x minus 1/2 x. Here we will rewrite 1/2 and 3/4 as similar fractions. LCD is equal to 4. Now 3/4 x minus 2/4 x, the difference is 1/4 x, then equals 8 minus 6 or positive 2. Multiplying both sides by 4, x will be equal to 2 times 4 or simply 8. Thus, the value of x is equal to 8. Now solving for segment AD, here we will substitute 8 to the variable x. That will become 3/4 times 8, product is equal to 6. Adding 6 and 6, the sum is equal to 12. Hence, segment AD is 12 units. Now for segment CD, it will be 1/2 times 8 plus 8. 1/2 of 8 is equal to 4. Adding 4 and 8, the sum is also equal to 12. This proves that the length of the segments bisected are equal. Lastly, solving for the length of segment AC, here we will add segment AD and segment CD. Adding 12 and 12, the sum is equal to 24 units. Moving to our second theorem, it states that the perpendicular bisector of a chord passes through the center of the circle. Just like in the previous theorem, we are going to follow SR inductive proof to prove this theorem. Given that the line PQ is the perpendicular bisector of chord AB, we need to prove that the line PQ passes through the center O. Constructing our statement reason table, we will begin by stating the given assumption. First statement would be line PQ is the perpendicular bisector of segment AB. Reason would be it is given. This assumption is already stated in the beginning of the proof. For our second statement, if line PQ is perpendicular to chord AB, then Q is the midpoint of chord AB. Reason for this is that the definition of perpendicular bisector. For the third statement, we conclude that segment AQ is congruent to segment BQ, since Q is the midpoint. Reason for this is that the definition of a midpoint. Next, for statement number 4, we will draw line segment connecting center O and points A and B. Reason for this, 2 points determine a line. Statement number 5, this is related to what we stated in number 4. Here, line segment OA and line segment OB become the radii of the circle O. Thus, segment OA is congruent to segment OB. Reason for this, radii of a circle are congruent. With this, we can now conclude that segment OA is equal to segment OB and segment AQ is equal to segment BQ. That is by definition of congruent segments. Hence, line PQ passes through O or O lies on line PQ. Reason, a point equidistant from the endpoint of a segment lies on the perpendicular bisector of the segment. And that ends our proof. As an application, in circle A, line DE intersect chord BC at point E, forming 90 degrees or a right angle. Question, if line DE will be extended, will it pass through the center of the circle? It is clear that based on the proof that we had, any line that bisects a chord will pass through the center of a circle. So the answer here is yes. Another example, applying the two theorems. In circle A line segment from the center is constructed such that it bisects chord BC at point D. If radius AB is 5 cm and chord BC is 8 cm, how long is AC and AD? For this item, we have to remember that as a line from the center bisects a chord, it forms 90 degrees or a right angle at the point of intersection. It also divides the chord's measure into two equal parts. Thus, segment BD and segment CD measures 4 units. For segment AC, since it is also a radius of a circle, its measure is just the same with segment AB. Thus, segment AC is also 5 centimeters. Now solving for segment AD, here we will apply a theorem often used in right triangle when solving for a length of side. That is the Pythagorean theorem. It is given by a squared plus b squared equals c squared, where c is the hypotenuse or the side opposite the 90 degree, that is also the longest side. Here that is the line segment AB. Then A and B are the legs, which are segment AD and segment BD. Equation will be the square of segment AD plus the square of segment BD equals the square of segment AB. Here we will transpose the square of segment BD to the right side. It will be negative. Substituting the values, the square of AD will be equal to 5 squared minus 4 squared. The square of 5 is 25 minus the square of 4 or 16. The difference is equal to 9. Getting the square root of both sides, line segment AD will be equal to square root of 9 or simply equal to 3. Hence, segment AD is 3 centimeters. Thank you for watching. God bless.